Hello everyone, myself Ashish Desai, Assistant Professor, Mechanical Department. Today we are going to discuss here in number second, that is fluid static. In that content we are discuss here the buoyancy and flotation. So first of all we go for the learning objective for this session. The first learning objective is to know the buoyancy and flotation. Second learning objective for this session is to know about Archimedes principles. So after this session some learning outcome is there. So first learning outcome is the student will able to explain buoyancy and flotation. Second learning outcome is the student will able to explain about Archimedes principle. So these are the learning outcomes. So in last lectures we are discussed regarding the hydrostatic forces on submerged bodies like horizontal surface, vertical surface, inclined surface and curved surface. Now we go for discussing regarding the buoyancy force. So first of all buoyancy. So whenever a body is immersed in a fluid, so there should be the force will tend to lift up. So here the body is lifted up due to a external, that is upward force, which is opposite to the weight of the object. That is called as buoyancy, or you can say which is opposite to the mm, center of gravity. So that is called as buoyancy. So actually the buoyancy is the lifted up the body for such conditions is known as buoyancy force. And now that working body principle is can say that when a body is wholly or partially filled, it is beyond lifted by a force which is equal to weight of the fluid displaced by the body, which is equal to weight of the fluid. So whenever the body is immersed against the water, so that time that can displace a weight of water displaced by a body which is equal to that object which is placed in a that water, or can say in liquid, or can say fluid. That is called as buoyancy. So again I repeat, whenever a body is immersed or fully immersed, or can say partially immersed over here, so that time the upward force can be to be lifted. So this tendency of immersed body is to immerse that fluid due to upward force, that upward force which is opposite to the center of gravity. So this center of gravity is called as buoyancy. And according to buoyancy, that Archimedes principle, when a body is partially, or can say wholly deep into the fluid, it is beyond or lifted up the force which is equal to weight of the fluid displaced by the body. So weight of the fluid displaced by the body. So here we can take example of that. So here we can lowering the objects. So after half of the, you can say, the object displaces, so that time water will be displaced into small container. And whenever the object is completely submerged, so that time the volume of the displaced water is equal to, so volume of water is displaced which is equal to volume of object. So this is called as Archimedes principle. So here is the force of buoyancy which is equal to weight of the solid. So here we can say that if the force of buoyancy which is equal to weight, so here the force of buoyancy which is opposite to the weight of object, so which is equals, that time the solid remain equilibrium. So both should be equal, then only it should be equilibrium. This is called as flotation. This is called as flotation. This is regarding the Archimedes principle. So always remember that whenever the force buoyancy which is equal to weight of the objects, so that time the solid will be remain in equilibrium. So this called as flotation. Now what the causes of buoyancy force? The buoyant force is the rises force or rising force on an object exerted by the surrounding fluid. So this is exerting by the surrounding fluid. When an object pushes water, the water pushes back with the as much force. So that's why if the water can push back as hard, the object floats. If not, it sinks. So example, steel. So this is regarding the buoyant force. So already know that whenever the object pushes the water back with a much force it can be. But if the water can push as hard, the object can float, and if it is not that float, that means it can sink. The example is steel. So this is regarding the causes of buoyant force. Now we go for center of buoyancy. So that point where the force of buoyancy which acts, that point is called as center of buoyancy. That means where the buoyancy force acts, that point is called as center of buoyancy. So the point of application of force of buoyancy, that is called as center of buoyancy. So it is always, remember that it always the earth kind center of gravity of the volume of wood displaced. So this is equal manner. So that is regarding the center of buoyancy. So easy term is there whenever the point through which the force of buoyancy is supposed to be act is known as center of pressure, again center of buoyancy. So in center of buoyancy, which is opposite to the weight of the object, in short we can say. Now we move for the example. So here a wooden block is having width. So width is 1.25, the height is 0.75, and length is 3 meter. So here that three-dimensional form is there. So I can say length is 3 meter and is floating in the water. So here the floating is water, and the specific weight of the water, or you can say wood, is 6.4 kilonewton per meter cube. Specific weight of wood is 6.4 kilonewton per meter cube. Find, so here find volume of water displaced. Second term is position of center of buoyancy. So first of all we go for the given data. So as you know that the width of the wooden block is equal to 1.25 meter, and depth of wooden block is a 0.75. Then length of wooden block is 3 meter. Now we go for the volume of this block, that becomes 2.812. So after this multiplication it is converted into meter cube, right? So here the specific weight of the wood, next term is given to you, that is specific weight of the wood is 6.4 kilonewton per meter cube. So kilonewton, that's why I can convert into newton, that is 6.4 into 1000 newton per meter cube. Now we go for the specific weight. What is specific weight actually? It is equal to weight upon volume, correct? So here volume is required, right? Specific weight is equal to weight upon volume. That is a relation because it is specific weight relation. So here we want volume, correct? So that's why we require the relation for that. Volume of the weight of the block is into specific weight into volume. Now we go for the specific weight, that is nothing but rho into g, volume. So volume is wooden block, we can place this, that is 2.182 and put 1.2. So after that we can get the weight of the block. So this weight of the block is 18 into 1000 newton. So that means it should be kilonewton, can write in terms of kilonewton. So it is simple example is there. Only when you calculate this volume after you reach the specific weight, so specific weight is equal to weight upon volume, then we can write as a weight of the block is equal to specific weight into volume. So specific weight we can put direct value. What is that specific weight value? Here it is clearly mentioned that 6.4. So 6.4 into 1000 you can write here into this meter cube, that is 2.812. So after this calculation of that, we can say that 18 into 1000 newton. So that is the weight of the block. Now we move for the next. So here we regarding the after that volume of water displaced, position of center of buoyancy is required. So this is required area. So here we have to calculate the weight of the block. So that nothing but volume of water displaced. So volume of water displaced is equal to. So I can write here weight of water displaced divided by weight density of water. So if you require volume of water displaced, that's why we can take weight of the block, then weight density of water. So weight density of water at the bottom of the side, that is denominator, and numerator we can say that weight of the water displaced, that means weight of the block. So here we can place the 18 into 1000, that is weight of the block, that means water displaced, and then weight of density, that's nothing but 1000. So after that we can take the, it cancels out, then after that we can get the value of 1.835 meter cube. So this is the volume of water displaced over here. The next point, it is asked about the position of center of buoyancy. So that relations for the position of center of buoyancy. So here the wooden block is there. We can take 1.25 into h, 1.25 into h into 3. So here we can take the volume of wooden block in water. So after placing that, 1.25 into h into 3. So 3 is the width. So that's why we can take 3. Here it is not shown 0.75, 1.25 is there. But width is 3. That's why volume of wooden block we can say 1.25 into h into 3. So we have to find out the center of buoyancy. That's why I can write volume of the block. Okay. So this is volume of the block. We can see that. And volume of water displaced. So it is given directly, that is 1.835. So after solution we can get the value of 1.8325 divided by 1.253. So that is the value of h. So this is h is equal to 0.489. So this is regarding the center of buoyancy. Center of buoyancy means where the buoyancy force is acted, that point is called as center of buoyancy. So here we can divide by 2, that means the center of buoyancy. So in that lecture we are to discuss here the how to formalize the volume of water displaced. So according to that we can say that it is easier method for finding out the volume of water displaced as well as the position of center of buoyancy. Now we move for a next example. So here the metallic cube is there, which is high inside the 30 centimeter and weighing is a 450 Newton, is lowered in a water tank. Then it contain of two water levels, that is mercury and water. So here we are placing after the cube, it is immersed into that liquid, that's mercury as well as water. Determine the position of blocks. So here we can find out the position of block at mercury water interface when it has been reached equilibrium. So first of all we require the given data here. So as per the principle of flotation, we have weight of cubical block is equal to buoyant force. So weight of the cubical block. So as you know that weight of the block means what? Specific weight into volume. So here, as you know that specific weight is equal to weight upon volume. So as per our requirement, we can write that a weight of water and mercury displaced by the block. That's why weight of the cube is equal to specific weight into volume. So here I can write specific weight, right? So I can write here specific weight into volume, correct? So first of all we go for specific, that is rho g. So here first of all we consider water is liquid is there, so that's why rho g h1. Rho g means rho is for 1000, g is for 9.1 and h1. So h1 is there, correct? So here we consider for volume also, that's why h1 into this 0.3 into 0.3. Why it is 0.3? Because we convert this, that 30 centimeter to 0.3 meter. So after that h1 into 0.3 into 0.3, that is the value for weight of the water, plus 13.6. So you can enter into the second liquid, 13.6 into 1000 into 9.1. So that is the next thing. And regarding the volume, so how to find out volume? So h2 upon 0.3 into 0.3, because h2 is the height for the mercury which is present over here, 0.3 is the weight, that base, and height is the, it is given directly, that is 0.3. So here actually h2 is unknown because h2 is the vertical distance. So after that equation we can get the h1 plus h2 value, that is equation number 1. Now we know that h1 plus h2. So from figure we can write h1 plus h2 is equal to 30 centimeter. So I write here h1 plus h2 is equal to 0.3 meter. So after solution of equation 1 and 2, we get the value of h2. h2 is equal to zero point 0.5 minus 0.3 divided by 12.6. So it is equal to 0.01658 meter. So this is regarding the metallic cube. Now we move for the next example, so which is based on the same phenomena, that is finding out the volume of stone and its specific gravity. So here stone weighing 392.4 Newton in air and 196.2 N, that is Newton, in water. So this is regarding the stone. So it is partially which is deeper into the air as well as water. So it is clear from figure. So compute the volume of stone and specific gravity. So here we have to calculate the volume and then we go for specific gravity. So first of all we know that the weight of stone. So what is the weight of stone here? In air, so this is present for air, that is 300 Newton, that is 92.4 Newton. This is for air. The next weight of stone in water. So here water, instead of that email is the, so here weight of the stone in air, that is 392.4. Weight of the stone in water is 196.2. Now as we know that the equilibrium conditions, weight in air, so weight in air minus weight of stone in water, so this is equal to weight of water displaced. So here 392 for air, for water purpose we can write 196.2 is equal to 1000 into 9.1, because weight is nothing but rho g into volume. Rho is the 1000, g is 9.1 into volume. So volume of water displaced. So here volume is, we have to calculate here. So therefore volume of water displaced, we can transfer this term, and after that we can get the 2 into 10 raised to 4 centimeter cube. So this is regarding the volume of stone. So this is volume of stone. So that equates equal to 2 into 10 raised to 4 centimeter cube. So this is regarding the volume of stone. After that we can go for specific gravity for the stone. So as we know that the weight in air divided by g, that is mass of stone. The mass of stone you can find out first. Mass of stone is equal to weight in air divided by g. 392.4 divided by 9.81, that is equal to 40 kg, that is 40 kg for mass. Now we move for the density of stone. So what is the density of stone here? Mass of air, or can say mass divided by volume. So we can put this value and find out the kg per meter cube, that is density of stone. So if you know that density of stone, then we can go for specific data for stone. So density of stone divided by density of water, can place over here, and then 2000 divided by 1000, it is equal to 2. So this is specific gravity for stone. So in this from in this numerical we have discussed regarding the finding out uh, the volume of water displaced when the two liquids are in placed in one container, and after that we can appropriate for the specific gravity of stone. So this is about 2. Now we go for the next problem, that is a body of dimension, that is 1.5 into 1 into 2 meter weighs 1962 Newton in water. Find its weight in air. So here this what will be the specific gravity? So same we can go for it. So volume of body is 1.5 1 into 2. So this volume, because it has giving dimensions, so we can take 1.5, separate out 1 here, 2 separate over here. After that multiplication it gives a 3 meter cube. And then next point is for weighing 1962 Newton. So this is regarding the weight of the fluid, or can say weight of the water. Now we go for the volume of water displaced. So volume of body is equal to 3 meter cube. That means volume of water displaced, that is 3 meter cube. And if you require in terms of weight, so weight of water displaced is equal to 1000 G9 into 3. So this is regarding the weight of water displaced. So that equation becomes 29,430 Newton. So this is water it can displaced. So in last lecture last point we discussed here the for the equilibrium of the body. So weight of the body in air and weight of the water displaced, that is called as weight in water. So if you plot this value for weight in air is unknown minus that weight water displaced, that is 29,430 is equal to 1962. So this is weight of the body in water. Now after that we can calculate the weight of air, that is the formula. Then next we can go for mass of the body is equal to, because m is equal to what, weight is equal to mg. So weight m is equal to weight upon g. So weight upon g can find out by this formula, that is 31392, that is from air g 9.81, and then it can get the 32,400 kg, 32 that 3200 kg, sorry, 3200 kg. So this is regarding the mass of the body. Now we go for specific gravity. So first of all we get the density for the body. So mass upon volume. So mass upon volume, it gets the value of that particular density. So mass is known to you, volume for the body. So here we can take a 3 because it is regarding the volume of water displaced is 3. So you can place 3200. So after that putting value, the density will get the 1066.67. So after that we can take the formula for that relations, that is specific gravity of the fluid is equal to that particular density, that is 1666 divided by 1000. This is for that density of water that is specifically mentioned over here, and then we get the value of specific gravity of the body, that is 1.067. So in this session we have to find out the water displaced from the when you put the body into the two interfaces or same interfaces. So this is regarding the session. Thank you.